This lesson we're going to talk about factoring as a tool to solve limit problems. So, for example, the limit as x goes to 4 of x squared minus 2x minus 8 over x minus 4. So we need to be able to factor or change the way that the numerator is written there so that we can cancel something out, because this is one of those problems where if we plug in 4, we're going to get 0 over 0. So we need to be able to simplify this rational limit problem in some way. And a good algebraic tool to have to solve these type of problems is factoring. And there are a couple of different types of factoring. So I'm just going to do a brief overview. So first, difference of squares. That means we have something like x squared minus 25. That's a difference of squares because it has a subtraction, and because both of the terms are something squared. So this term is x squared, and then the second term is 25, or 5 squared. So the difference of squares pattern is a squared minus b squared, and it factors to a plus b times a minus b. So in this particular problem, what we have is we have x squared minus 25, which we're going to rewrite as 5 squared, so that's going to factor to instead of x squared, we're going to write just x first in each parentheses, and then b, we're going to plug in 5 for b, because b squared and 5 squared, so b is just going to be 5, so our factored form is x plus 5 and x minus 5. So by writing something in factored form and with these two separate factors in parentheses, it means for a limit problem like this one, we might be able to cancel out something with this bottom factor. Okay, so that's difference of squares. It only works when you have a difference between two perfect squares. And one of those is going to be x squared. Three-term factoring is when you have something like x squared plus 7x plus 12. And again, we're going to try to turn that into two sets of parentheses. And in order to factor with three terms, we want to find, well, what are the two numbers that are going to go with x in this factored form? As in this difference of squares examples, the numbers were 5 and -5 that went with the x's. So we want to know what numbers go here in the factored form. The way that we're going to figure that out is we're going to think about the numbers that we have in this expanded or standard form. And what we have is a 12. I'm going to write that up here. That's a product that we're going to be looking for. And then we have, for our x term, we have a 7. And that's going to be the sum that we're looking for. So by product and sum, I mean we're going to look for two numbers to write with the x's in parentheses, whose product is 12, so that means they multiply to 12, and whose sum is 7, so they add to 7. So to do this, you might see the numbers right away, or sometimes it's a good idea to just kind of list out the factor pairs that make 12. So 1 and 12, -1 and -12, 2 and 6, -2 and -6, 3 and 4, -3 and -4. And we're looking for the pair that sum to 7. So 1 plus 12 right here is 13, so that's definitely not it. And 2 plus 6 is 8. We want a sum of 7, so the numbers we want are 3 and 4. We want them to both be positive because positive 3 times positive 4 is positive 12, which is our end number here. And then positive 3 plus positive 4 is 7, positive 7, which is our middle term here. So that means that our factored form is going to be x plus 3 times x plus 4. Okay, we're going to do another example of that type. This time we're going to try to factor x squared plus 2x minus 15. So this time we're trying to get a product of this constant number, negative 15. So we keep the signs, product of negative 15. And we're going to try to get a sum of the middle term, or the x term, which is positive 2. So as before, I'm going to list out the factor pairs of negative 15, or the numbers that multiply to negative 15. So now to multiply to negative 15, to get a negative number from two numbers, you need to be multiplying a positive and a negative. So that means my factor pairs are going to look like positive 1 times negative 15, negative 1 times positive 15, positive 3 times negative 5, and negative 3 times positive 5. Those are the only integer numbers that multiply to give negative 15. And now we're looking for a sum of positive 2. 1 plus negative 15 for this first pair is negative 14. The pair that we want is negative 3 and positive 5. Because negative 3 times positive 5 is negative 15, and negative 3 plus 5 is positive 2. So that means our factored form is x minus 3, x plus 5. Okay, so that's factoring with 3 terms, and you might also see some problems where you have 4 terms. So for example, x squared minus 4x, x to the third minus 4x squared plus 12x minus 48. Okay, here we're going to do factor by grouping. And the steps for factor by grouping is, well, first you're going to use it when you have 4 terms, or sometimes when you have 3 terms, but you can't figure out how to do it this way, you might have to split what you have into 4 terms instead of 3. But in this case, we have 4 terms. What we're going to do is we're going to group the terms 2 by 2. So that means we're going to group the first 2 and the last 2. And then we're going to look at the greatest common factor, the GCF, of those sets of terms. So these first 2 terms, they don't have a number in common, but they do have a power of x in common. They have an x squared power in common that could be divided out. The second 2 terms don't have any x powers in common, but they do have the number 12 in common, so their GCF would be 12. And then in each of these pairs of 2 numbers, we're going to factor out that GCF. So this first pair, we're going to factor out x squared. In the second pair, we're going to factor out 12. And then we're going to rewrite what we have left if we factor x squared and 12 out. So out of this first term, if we take x squared and we factor out, or x to the third and we factor out x squared, we're left with x. We take negative 4x squared and factor out an x squared, we're left with negative 4. Second set, if we take 12 and factor out 12, or 12x and factor out 12, we're left just with the x. And negative 48 factoring out 12 is negative 4. So when I say factor out, I really mean dividing. We're dividing out this GCF term. This doesn't quite look like the factored form of the others yet, so there's one more step, and that is to write this factor, which should always be in common between the two terms if you've grouped correctly. So that is our first part of factored form is x minus 4. And then the second part of factored form is the outside numbers, so x squared and 12. So x minus 4 times x squared plus 12. And that is our factored form now. Okay, so now let's do one problem of just applying these to a limit problem. So return to the limit problem that's written at the top here. Limit x goes to 4, x squared minus 2x minus 8 over x minus 4. And now we don't have anything we can cancel out yet. We need a full factor to be able to simplify this, but we could try and factor the numerator here. So let's try to factor that. So the factoring means we're trying to find a product. This is a 3-term factoring problem, so just like this type here, we're trying to find a factor of negative 8 and a sum of positive 2, or negative 2, because that's our middle term here. So I'm going to list out the factor pairs of negative 8. And again, since it's negative 8, we have a positive and a negative. So positive 1, negative 8, negative 1, positive 8, positive 2, negative 4, negative 2, positive 4 are the pairs of numbers that multiply to negative 8. And now we want two numbers that sum to negative 2. So that is these two numbers, 2 and negative 4. So what this means is we can rewrite our limit problem now in factored form. So it's going to be the limit as x goes to 4. I'm going to rewrite the x minus 4 on the bottom. And then the numerator we're now going to turn into factored form with these two factors, x plus 4 and x plus 2 and x minus 4. And then we can cancel out this x minus 4 term. And we get the limit as x goes to 4 of x plus 2. And now we can just evaluate this limit because there's no longer an error in the equation. So that means just plug in the 4 for x. So this limit is going to be 4 plus 2, which is 6. So factoring in all of these different ways, it's really just a tool to be able to simplify these algebraic limits.